back to my channel. And I am Siddharth, and today we will discuss about the topic clustering. It is very important topic in our data science. So here we go. Firstly, we will see what we will cover today in our topics. So firstly, we cover introduction, what is clustering basically is, and then demonstrate application of k-mean clustering using R or Python. Now, introduction. Firstly, clustering is the one of the most important technique in unsupervised learning, where the goal is to organize data into groups or clusters that exhibit similar characteristics. It helps reveal patterns and structures in data sets without any prior knowledge of labels or categories. Especially, clustering algorithms try to partition data based on inherent similarities or distances between data points. So, key objectives of clustering. Firstly, group similar data points. The primary aim of clustering is to identify data points that are similar and group them together. Similarity is typically defined by some mathematical distance or similarity measures. Next is find hidden patterns. It helps identify underlying structures, trends, or patterns within a data set which may not be immediately obvious. Next is data summarization. Clustering can be used to reduce the complexity of the data set by summarizing the data into a smaller number of groups or clusters. Next is outlier detection. Sorry. Clustering detection also helps in identifying outliers, data points that don't belong to any group, which can be useful for anomaly detection. Popular clustering algorithms are as follows. Firstly, we will see k-mean clustering. How it works? The user specifies the number of clusters, which is k. The algorithm randomly initializes k centroids and assigns each data points to the closest centroid. The centroids are the rectangulated the centroids are recalculated based on the mean of the assigned points, and the process repeats until the centroids no longer change. Next is hierarchical clustering. How it works? Agglomerative bottom-up starts with each data point as its own cluster and progressively merges the closest cluster. Next is division, which is top-down. It starts with all point in one cluster and recursively splits them. Next, we will see application of clustering. So firstly, it is used in customer segmentation as businesses use clustering to group customers based on purchasing behavior, enabling targeted marketing and personalized services. Next is image segmentation. In computer vision, clustering is used to segment an image into distinct regions based on pixel similarity, often to simplify or classify visual information. Anomaly detection. Outliers or anomalies in the data sets such as fraud detection or network intrusion can be detected by identifying points that do not belong to any cluster. Next is document clustering. In natural language processing NLP, clustering is used to group similar documents together, enabling topic modeling, recommendation systems, or organizing large data sets. Next, clustering can be also used in biology as clustering is used in genomics to group genes or organisms that exhibit similar characteristics, often based on gene expression data. Now, we will see a coding example of k-mean clustering with the help of Google Colab. As you can see here, firstly, we imported Panda, necessary libraries like Panda SPD, NumPy as NP, import matplotlib at .pyplot splt, and from sklearn.cluster import k-means. Now let's take sample data. We sample the data by data is equal to feature1 np.random.rand of 100 and feature2 np.random.rand 100, and df is equal to pd.dataframe of data. Now we apply k-mean clustering. K-means is equal to k-means of n cluster is equal to 3 and random state is equal to 42. df of cluster is equal to k-means dot fit predict df of feature 1 and feature 2. Now we plot the clusters as plt dot scatter df of feature 1 and df of feature 2. C is equal to df of cluster and cmap is equal to viridis, and plt dot scatter is equal to K means dot cluster centers colon 0 and K means dot cluster center colon 1. S is equal to 300, C is equal to red, so color will be red and marker will be X. Now PLT dot X label which is feature 1, PLT dot Y label which is feature 2 and PLT dot title which is K means clustering and PLT dot show. As we run this, I already done this before and you can see here red cross which we stated here. The marker will be X and color will be red. And in on the y-axis there is a feature 2, in x-axis there is a feature 1, and this is the k-mean clustering graph diagram. So we have completed our today's topic. So yeah, so thank you for watching. Please stay tuned for upcoming content. Thank you.